Good morning. I am Dr. Ashok Kumar, Associate Professor in the Department of Mechanical Engineering. I am going to give a lecture about the parabola. Before the parabola, first we should know about cone. What is cone? Cone is a revolutionary object. It is obtained by revolution of triangle by its own axis. That is called cone. So what is conics? Conics are defined as the curve obtained by cutting a right circular plane with section planes kept at different inclinations with the axis of the cone. Here the consider a plane which is parallel to the base. A cone is cut by a parallel plane, then we can get a circle as its top view. Suppose if the cutting plane is inclined to the axis of the cone, then we can get ellipse. When the cutting plane is inclined to the axis and also parallel to one of its generators, then the true shape is parabola. So generators are imaginary lines. We can select 8 or 12 based on the number of requirements. We can select the number of generators as its own. So today we are going to discuss about parabola. So there are various methods to draw the parabola, but in our analytic syllabus we have eccentricity method. So what is eccentricity? So eccentricity is the ratio between the distance of moving point from focus and distance of moving point from directrix. What is focus? The fixed point in the axis is called focus. The fixed straight line is called directrix. That is, it is perpendicular to the axis. So what is the axis? The line perpendicular to the directrix and passing through the focus is called axis. So eccentricity is the distance of moving point from focus to distance of moving point from directrix. When the eccentricity value is less than 1, then the curve obtained is called ellipse. If it is equal to 1, then we can get parabola. So this is the point F, which is called focus point. So these are the points called vertex points. So this line is called directrix. This line perpendicular to the directrix is called axis. So when the eccentricity ratio is equal to 1, then we can get parabola curve. So we are going to see a parabola and how we can draw it in engineering graphics. So the problem is draw a parabola when the distance between the focus and directrix is 30 mm and the eccentricity in is 1. So as we discussed earlier, the eccentricity ratio is equal to 1, we can get parabola curve. So I am going to tell about the procedure to draw the parabola curve. First, draw the line AB, that is called directrix. Next, draw the axis perpendicular to the directrix through any point C on it. Next, mark the focus point F such that CF equal to 30 mm. Since the eccentricity of parabola is equal to 1, the vertex D can be located at the midpoint of CF. So it is located between C and F, that is distance CD equal to DF. Draw a perpendicular line DG at point D such that DG equal to DF. That is, DF length is here 15 mm. So DG equal to 15 mm. Draw a line joining C and G and extend it. This line is inclined to the axis line. Next, mark a point 1 on the axis and draw a perpendicular line 1 to intersect at 1 dash on CG. Next, with F as center and length 1 dash as radius, draw an arc cutting the line 1 dash at points 1 and 1 dash, that is above and below the axis line. Similarly, marks 2, 3, 4 up to 8 on line CE and get the points 21, 31, 41 up to 81 and 21 dash, 31 dash, 41 dash up to 81 dash. Join these points by smooth curve. We can get the required parabola curve. So finally we can get the smooth parabola curve. Next, we are going to draw tangent and normal lines to the parabola curve. See here mark P point at anywhere in the parabola curve. Join that P point with focus point. Next, draw the line perpendicular to FP and meets the line in AB at Q. Draw a line through P and Q. This line is required tangent line. Through P, draw a line PR perpendicular to PQ. This line PR is normal to the parabola at point P. Thank you.